In the traditional environment, software distribution always occurs as a one-to-many model. Whether it's a distribution point serving content to workstations or carefully elected peer, it is still the job of one to share its content with all the others, and this doesn't work because flaws in the network lead to latency or worse, drops with no way to recover. Networks can get flooded by retries, which leads to throttling of distribution points or throttling of peers. It's not uncommon to see 20% of the bandwidth reserved for ConfigMgr type transmissions, leaving 80% left for the business to do normal business operations. But what happens when you need more or less of that bandwidth for either side of the equation? This also requires complex setup, if it's even allowed at all, to be done by other specialized teams, meaning it's taking resources from other teams to take care of actions. Sometimes these things need to be reconfigured as hardware is moved in and out of inventory. Adaptiva's memory pipeline architecture technology is different because it's fault-tolerant, meaning that it can recover from clients that go offline. Peer-to-peer is happening in memory in 1K packets so that system resources aren't killed just to share content. Machine A receives its content from over the WAN and puts it in memory 1K at a time, and then as it writes it to disk, machine B grabs that content that's in memory, puts it in its own memory, and then writes it to disk and passes it on to machine C. So there's only one write operation per 1K packet. It's built on a super efficient protocol based on lightweight connectionless UDP, and it's a self-forming peer-to-peer pipeline, meaning that there's no need for administrative intervention, which frees teams of people to focus on other priorities. Here I have a VM in Chicago. Host name is Win10036, and it's in the 192.168.4 address range. If I open cmtrace, I can see that it started downloading a ConfigMgr package. Its package ID ends in 24. If I start zoom it, I can show you that it's actually started downloading from elsewhere on the WAN. The log file actually shows you that this is a WAN transfer. This is downloading from my site server, which has an IP address of 192.168.1.214. So again, this is a true WAN download. If I open up my Adaptiva cache folder, I can see that this piece of content has actually downloaded. Now it's actually a lot larger than this, so as it starts to download, I'll see the size bump up. However, this is a T1 connection, so we won't see a huge jump in this video lab. What I can do is open up Resource Monitor and show you that while the content is downloading, it's actively transferring in memory or sharing peer-to-peer in memory to another client, Win10032. If I open up Win10032, I can see that it has an IP address of 192.168.4.102, so it puts it on the same IP address range of the other machine we were just looking at. If I open up the exact same log and I look and see that it's downloading the same ConfigMgr package, which ends with 24 in its ID, and I read the log and I look and see that this time around, the download is happening over the LAN, and the IP address that it's coming from is on the same subnet rather than downloading over the WAN, which means that this entire ConfigMgr package isn't reaching out to the distribution point that's on the other end of this WAN link. It's actually reaching out to another peer, the peer we were just looking at, to get the packets and to send it over that way rather than transferring it over the WAN. So to recap, this isn't a one-to-many approach. It's actually much different. The first peer is reaching over the WAN to download the package that it needs, and as it starts downloading, it puts it in memory and then shares it with the next peer that's in line, who then shares it with the next peer in line, and so on, as you can see in the illustration. This video shows you how Adaptiva's memory pipeline architecture changes the game of content delivery by beginning the peer-to-peer process in a very efficient and lightweight manner. Thank you for watching.